Hey there, today we're going to build a full stack cryptocurrency application using the Coinbase API. So we're going to build our own user registration system that allows us to create accounts and save them. And then we're going to use Coinbase's OAuth flow to authorize our Coinbase account. And then we can use that to reach out to their API, retrieve a list of our transactions from Coinbase, and build out a dashboard. So let's go ahead and get started. We're going to start our project by building out the UI using React, Redux Toolkit, and Material UI. So make sure you cd into the directory where you want to initialize the application. And we'll go ahead and use create React app to bootstrap our React. So I'll call it npx create React app, and you can call it crypto stats or whatever name you'd like. And then we're going to pass a template of Redux TypeScript. So after we've successfully installed the app, we can cd into it and run yarn start. This will start the development server so that as we make changes in our editor, the browser will automatically update. Once you're at localhost 3000, you should see the starter template that comes with Redux TypeScript out of the box. So after we open up the project in a code editor, I'm going to open up the source folder. And in here you can see the bootstrapped files that Create React app is created for us. We have our index.tsx that it is instantiating the provider with a store, which if we go under the app folder, we can see the Redux store has been created and they have a sample counter reducer set up for us already. So let's go ahead right away and open up app.tsx. I'll go ahead and remove the boilerplate JSX in here, and then we can go ahead and remove all of these unused imports. And the first component that we want to start off with is a sign in and sign up form. So I'm going to go ahead and create a new folder in the source directory called components, and I'll create a new folder in here called auth, which will host all of our auth related components. And we're going to go ahead and create another folder in here called login form. So this is going to be the first component we start off with, the login form. So I'll create a login form component.tsx. We'll go ahead and import React and then set up the component. And for now, we'll just go ahead and return some empty JSX and export the login form. So now in our app.tsx, let's go ahead and actually use the login form component. And so now we can go ahead and actually start building out this form. In order to do that, let's go ahead and install the Material UI library that we'll be using for this project. So we can actually go ahead and open up a new terminal, and we can go ahead and add this command. So this is going to install the dependency for us. And then we're also going to want to include the default font and a set of icons that Material UI uses. So let's go ahead and open up the public folder. We'll open up index.html, and let's go ahead and include this link to the Roboto Google API fonts. And then we'll do the same thing for the icons that are used. So this is everything we need to get Material UI set up. I'm going to go ahead and also install Tailwind CSS so that we can apply some easy styling to our application and make things look a little bit nicer without having to create unnecessary style sheets and deal with annoying class names. So go ahead and yarn add -d the following dependencies. I'll include the commands I used to add all the dependencies in the description. Lastly, we need to do a yarn add Krakow in order for Create React app to use our Tailwind styles. Lastly, we'll go into the package.json and we'll change out our scripts here for Krakow start, build, and test. And we'll create a krakow.config.js, and we'll go ahead and paste the default configuration that tells it to use Tailwind CSS. Let's go ahead and open the terminal back up, and let's run npx tailwind css CLI latest init to init Tailwind in our project. This will create a minimal Tailwind config file at the root of our project. Let's go ahead and configure the purge setting with all the paths of our components so that Tailwind can tree shake unused styles in production builds and make our app even lighter. So go ahead and paste that into the purge array. And the last thing we have to do is just import the Tailwind CSS directives into our index.css file. So I'll get rid of all this default styling and then include these 3 tailwind directives. And then make sure we actually go back into our app.tsx and import the index.css file. We're also going to use the dark mode in our application just to make things look a bit nicer. So I'm going to specify for dark mode to use the class setting. And then we're also going to specify the default font family here. So for the sans fonts, we're going to use Roboto as our default font. Lastly, make sure you restart your development server before we continue, as we've changed the start command in our package.json. Okay, the first thing we're going to go ahead and do is wrap our login form in a div, and I'm going to give it a class name of flex, and so we're using tailwind here to apply styling. So we're going to justify center, items center. We're going to use flex column, and because I want the login screen or the login form to be centered on the page, we're going to use height screen. And then we're going to give things a gap of 8 to give things a little bit of space. And then I'm going to go ahead and create an H1. I'm going to use a title of crypto stats just so we have a title for our form. Next, I'm going to go ahead and create a new div. I'm going to use flex column and gap 2. We're going to open up this div in here, and this is where we're actually going to have our input fields. So I'm going to have a text field, and make sure we're importing the text field from material UI material. And now we can give this a bit of information. So we know the label is going to be email. Let's give it a class name. So we'll give it a width of 80. We'll specify the type is an email field, which will give us some out-of-the-box validation. And then for now, we're just going to also specify that it's a required field. We'll create another text field, and this one will be for the password. So we'll give it a label of password. Type will also be password, which will hide the characters as they're being entered. Similarly, we'll give it another class name of width 80, and this will also be required. So next, we're going to add our button from material UI material. I'm going to use the contain variant, which will outline the button, and this will be our submit button. So we'll give it a width of 80 to keep it consistent. For now, we will not have an on-click listener, so we'll close this out, and then I'll just create a span and give it a label of login, and I'll give it a class name of padding 1 just to give it a bit of space. And lastly, let's just go ahead and give our H1 here, let's just give it a class of text 6XL. So now if we look at our form, we can see we are able to enter an email, a password, and log in. I'm not really a huge fan of the kind of blinding white we have going on here, so let's go ahead and implement dark mode. So there's 2 things we need to do to implement a dark mode. The first is to implement a custom theme using Material UI. So to do this, we're going to open app.tsx. I'll create a new const here called dark theme, and we'll call create theme. Import this from Material UI material, and now we can specify the palette property, and it has a mode, and we can specify dark. So now we are able to provide this dark theme to our whole app. In order to take advantage of that, let's go ahead and use the theme provider that Material UI provides us. So now we can specify our login form and all the other components that we have instead, and we're going to have to wrap this in our return. And now we can also provide the theme to the theme provider. So we have our dark theme that we just created. So now all other components in the tree from here on will use the dark theme that we've provided. So now we can see our components here are using a darker variant, but we need to do a bit more work on our text and our background. So if you remember previously when we started our tailwind config file here, we specified the dark mode should be enabled via classes. So let's go ahead and actually implement that. If we go into our public folder in our index.html, on our body tag here, we're actually going to specify a class, and we're going to give it dark background gray 800, dark text gray 200. And what this is going to do is it's going to apply these styles if the dark mode is enabled. HTML tag itself will apply the dark mode class. Now, you could implement some sort of feature to toggle this dark mode class, which would change the dark mode on the entire app. We can now see we have a nice dark mode. So with our login page complete, we now need to implement the sign up form so that users can actually create accounts. So before we do that, we're going to need some way to navigate to the sign up page from the login form, as well as the other pages that we'll be using later on in the app. So to accomplish this, we're going to use React Router. So let's go ahead and install React Router. We'll open our terminal back up and run yarn add React Router DOM at 6. Okay, so now let's go ahead and open up our index.tsx file, and now we need to wrap our whole app around the router so that we can navigate and respond to route changes from anywhere in our app. Kind of similar to how we set up the theme provider, we need to wrap everything in the browser router. So we'll wrap the whole app in the browser router. So I'll go ahead and actually create a new folder called routes, which will host all of the different routes in our application. I'll then go ahead and create a routes.tsx file. And this is just going to be another React component, but it's going to host all of the routes in our app. So now in this component, we need to wrap all of our routes in the React Router routes component. So in order to do that, let's go ahead and import routes. And I'm going to report them as React Router routes because this will be the same name as our own routes component. So we also want to import the route itself, and this is going to be from React Router DOM. So now let's wrap everything in React Router routes. So now we can specify the routes that we want to include in our app. So we could include the components directly, but I like to create a separate folder called pages, which will host the actual routes themselves, and then on these pages we can include the components that we'd like. So to see what I mean, I will create a login page.tsx and a signup page.tsx. And let's just go ahead and copy the existing JSX we have from the routes, and we'll just go ahead and change this to login page. And we know the login page is simply going to turn the login form as we've set up, and we can export the login page, and we'll do the same thing for the sign up page. Right now we don't have a sign up form, so for now we'll just have the login form. So let's go back to our routes. Inside of this React Router routes here, we can include our first route. So this route will have a path of login, and we specified the element, which we know is the login page itself. And that's all we need to do. Similarly, we have a path for sign up, and it takes an element which we know will be the sign up page. So once we close this out, we can export the routes. And now if we go back to our app.tsx, instead of including the login form here as our root component, we will render the routes that we've set up, and make sure we import this from the routes ourselves that we've created. So in our login form component, I'll go ahead and include a link from React Router DOM, and here we can specify the route that we want to link to. So in the login page, we want to include a link to the signup page so that users can create an account if they don't have one. I'll give this a little bit of styling. I want to justify self-start, and margin top 2. And for the link text here, we're going to actually import from Material UI, we're going to import link as Material UI link, which is their own link that applies some styling. So here we can actually wrap our text in Material UI link, and we'll say sign up. So now if we take another look at our app, we don't see anything being rendered, and that's because by default we haven't specified a route on the home page. So if we actually navigate to the login form, we now see we have the sign up link, and on the sign up page you can see we've been correctly navigated to the correct route. So let's work on implementing a dedicated sign up form so that we can implement our own logic and change some of the text here. So in the auth folder, I'll create a new folder called signup form. This will be very similar to the login form, so we can pretty much copy most of this JSX, and we'll create a new component, signup form.component. Let's paste our existing login form in here and change a few things. So first, we'll change the name of the component, login, instead of sign up, so that if the user already does have an account, they can navigate to the login form. Lastly, we will change the login button to sign up, and make sure we are exporting the sign up form here. So now let's go back into our sign up page, and instead of rendering the login form here, we will render the sign up form. So now back on the sign up page, we can see we have the correct sign up button here, and we can navigate to log in. So now that we have these two forms, let's implement some logic so that we can actually validate some of this input here and use it to send this to our server. That will create a new piece of state called email, and we'll use state and make sure this is properly imported. And by default, this will be an empty string. We're also gonna have a piece of state that will specify whether the email is in an error state. So by default, this will be false. So now we're gonna do the same thing for the password here. We'll have a password, a set password function, and then we'll be able to specify if the password is in an error state. So now we can flesh out our text fields down here with a bit more of logic. On the email, I'm going to specify a helper text property here that will say if the email is currently errored, then I want to have a message that says please enter a valid email. So this will be triggered if the user doesn't enter a valid email, because we have the email type here as well as the required property. We'll also provide it with the value email, and then have an on-change listener here that gets access to the event, and then we can call set email and use the event target dot value. And then we're going to go ahead and do the same exact thing here for the password. Obviously, this is going to just change to the password error, and now we can say password may not be empty, because that's the only validation we're applying here to the password. Make sure we give it the correct value and that we're setting the password here. Lastly, I'm going to go ahead and set up a handle signup method here, which is going to validate that the user actually entered an email and a password correctly. So we will say if the user did not supply an email, we'll set the email errored to true. We'll say if the user didn't supply a password, then we'll do the same thing for the password. And then in order to remove errors, if they already exist, I'll add an else clause to both of these and say set email errored false, and it'll do the same thing for password. So set password errored false. And now we can use this handle signup method on our button down here, which will later actually send data to our server in order to create the user. But for now, we'll just make sure that our validation is working. So we'll have an on-click listener that is past the handle signup function here. And we also want to make sure that we specify the error field here. So we'll have email errored, and we'll do the same thing for password here, so that if there is an error, the fields will be highlighted and the user can correct the error. So now if we come back up to our signup page and try removing the input we've provided and try signing up, we correctly get some validation messages here. And if we provide some values, we are able to sign up. Now let's go ahead and set up the same logic for our login form. And to save some time here, we can actually just copy the text fields that we've created, and let's paste them here to the text fields in the login form. We'll of course have to also include the sign up and the use state calls here. So we can paste these through here and make sure we import use state from React, and then we'll add the on-click listener to our button down below. So instead of handle signup, we'll change this to handle login. So now on the login form, we have the same validation that we set up previously on the signup form. So we're going to use Nest.js as the backend for our project. I've opened up a new terminal tab, and I'm going to run nest new and call it cryptostats backend. So that Nest will automatically generate our application. I'll use Yarn as my package manager. So go ahead and let this installation finish up. So once the installation finishes, we can cd into the backend here and run yarn start dev. So after that installation finishes, I'm back in my code editor here, and in VS Code, I'm actually going to choose this option to add folder to workspace here. And then I'm going to add the cryptostats backend that we just created so that we can have both of our projects sitting here nicely. And I'm actually going to change the port we're listening on to 3002 because the React app is listening on port 3000, and I have some other apps that are listening. So you can change this to whatever open port you have available. Okay, so the first thing we're going to need to do is to be able to set up our database so that we can persist users after they sign up. So what I'll go ahead and do is I'll open up my terminal and make sure we open it in the back end here. And I'm going to yarn add Nest.js / mongoose, and then mongoose itself. So mongoose is the ORM that we're going to use to allow us to connect to MongoDB. Now we're also going to go ahead and add one more package for now, and that's going to be Nest.js / config, which will allow us to inject environment variables from an environment file into our application. So this is going to be particularly useful because when we need to specify the connection URI for MongoDB, it's going to be different for when we deploy our application and for when we're developing locally. So to see this in action, let's create an environment file in our backend here. This is where we're going to store all of our environment variables. In this file, we would not check in to Git, so we could keep sensitive information in here that we need to inject into our application at runtime, and that can change in between different environments. So for now, we'll specify our MongoDB URI, and when we're running locally, the URI will be MongoDB localhost, and then we can specify the database, so this will be cryptostats. So now let's go into our app module here, and in the imports array, we can import the mongoose module. We'll call for_root async, and now we can specify a set of imports for our for_root module here. We're going to need the config module because we're going to use it shortly. Then we'll use the use factory, which will allow us to inject services, which we'll want to do to be able to get access to the config service that Nest.js offers us, and make sure we import this from Nest.js config. And then we will specify the URI. We'll use the config service .get. We know this is a string, so we can provide some type information here, and then we can finally extract the MongoDB URI. Lastly, to make sure we can actually use the config module in our application, we need to import the config module itself, and it has its own for_root call here. And I'm also going to make this a global module so that we can use it anywhere and we don't have to keep re-importing it. Finally, now that we've instantiated the config module, we need to actually inject it here so that it is available. So we inject the config service here. Now, after you restart your development server, you should have access to the URI that we're injecting here. If you find that you have any build errors in your backend application, try updating and make sure you update your Nest.js packages to the latest versions that I'm using here. So this includes the Common, Core, Platform Express, RxJS package, and then also make sure you are using TypeScript latest version here. So now we're ready to start building out our logic around users in our application. So I'll open up a terminal here in the backend, and we can use the Nest CLI to create a controller. Actually, start with the users module. So this will have Nest automatically create a new module for us and then add it to the app module here. So we'll also add a controller for users, and then lastly a service. So with these three commands, we've created a new users module with a controller and a service. So let's go ahead and open up our controller here. So the first route we're going to add is the ability to create a new user. So this will be an asynchronous method. We'll call it create user. And then we know it's going to return a promise. And for now, we'll just leave it as any. And we'll leave the body empty. So let's first create a new folder here called data transfer object, where we can define the requests that are coming into our system. So in this case, we have a create user request that we know is going to be passed into this route here. So we'll export a class create user request. And we know that we're going to provide an email, which is a type string, as well as a password of type string. Now we want to be able to validate any input coming into our system here. So in order to do that, we can take advantage of another out-of-the-box solution that Nest.js offers us using class validator. So I'll yarn add class validator and class transformer, which will allow us to apply decorators to these properties and have Nest automatically validate them. So now we can add some of these decorators. We can say that this email should be an email, which will also check to make sure that it's a valid email. And then we have a password here, which we know should be a string, and it also should not be an empty string. And to actually set this up in our main.ts file here, we need to make sure that we apply a global pipe here. And this will be a validation pipe that we import from Nest.js common so that our input or our requests are properly validated as they come into our controllers. So now back in the user's controller, we could specify the body here of create user request. We know this is create user request of type create user request. So we'll need access to the user service here so that we can dispatch actions to it and keep all of our domain business logic abstracted away from our controller. So in here, we're simply going to call this.userService, and we will have a method in there called createUser that takes the createUser request. So let's go ahead and start building that out in our user service. We will have the same method in our user service here, an async createUser that takes the createUser request as we just specified in the controller. We don't have a return type yet, so we will keep it as any. And now we need to be able to reach out to a repository to actually persist this user in a database. So to do that, I will create a new file here called users.repository, and this is going to be a Nest.js injectable so that we can use dependency injection here, and it will simply be a class called users repository. Now, before we can actually set up our repository, we need to define a model for what our user looks like, a schema, if you will. So in order to do that, I will create a separate folder here in our users directory called models, and I will create user.ts. So now we can specify that this is a schema, and I'm going to set the version key to false for this because I don't want to have to deal with versioning in the database. So we can simply export a class called user, and we know it extends a document, right? A document which we import from Mongoose. So make sure we import the document from Mongoose here. And now we can specify the properties we know that will exist on the user. So for now, we know we're just going to have an email and a password, which are just two strings. And all we have to do is decorate these with the prop decorator from Nest.js Mongoose. So, and then we're also going to export a const called user schema, which we'll call schema factory, dot create for class, and we pass in the user, and we see now that we can actually use this user schema in our users module. We need to add an import here to tell Mongoose about this schema, because this schema is what is actually going to create the user's collection under the hood. If you wanted to specify a different name for your collection, you could do here, but by default it's going to take the name of the class and just pluralize it into users, lowercase. So we'll import the Mongoose module as we've done, but this time we'll call for feature, and this takes an array of models. So we have a model we just set up. It takes the name of the model. We can specify the name of the user class we created, and then it wants the schema, and of course we've exported this already. So now Mongoose knows about our schema. It will create a collection for us as soon as we insert our first document. Now back in our users repository, we can make use of this schema and actually work with it. So to do that, I will have a constructor here, and we're going to call inject model from Nest.js Mongoose, which is a decorator that takes the name of the schema that you are wanting to inject. So we have a user here, which is a type model, and it is a user. So make sure we specify it like that. Of course, make sure we add our imports for these. So the user comes from the models directory, and this model tag here is imported from Mongoose. Now we have everything we need to actually persist data to our user's collection. I'll create an async insert one method. So this takes data, which I'll specify as a partial of the existing user that we have, because by default we extend the document in here, and I don't want to have to provide all of those properties. And then so this is going to be a promise that then returns the newly created user. So I'm going to say user is new this.user, pass in the data, and then I'm going to return user.save so that we return it back to the caller. And of course, make sure in our users module that we provide the users repository here so that Nest.js knows about it. And more importantly, we can actually inject it now into our user service. So add a constructor, a private read-only users repository here, as we have done in the past. And now we can make use of this repository. And all we're going to do for now is we are going to return this .users repository .insert1 with the create user request, because of course this does include the email and the password. So to actually test this out, I've opened up Postman here, and we're using the URL localhost with the port that we specified in our main.ts. So in my case, it's 3002, and we are reaching out to the user's endpoint with a post request, and you can see here we have our email and password, and if we send this off we get the newly created user sent back. And in the database here we can see our collection of users grow as we insert more. And just to test our validation out, if we were to leave the password as empty or not have a valid email, the server responds with a 400 status code. So part of building a secure API and backend is, of course, always being prepared for hackers or some outside entity gaining access to your data. And of course, you can see here that both we're returning the password back to our client, but we're also storing it in plain text in our database, and if this database is ever compromised, we don't want these passwords being revealed to the outside world. So in order to get around this, before we actually insert the document into our database, we want to hash the password so that it's not in plain text. We're going to use the bcrypt library, which will allow us to hash passwords and then compare them. We'll still return this .users repository .insert1, and we'll spread the whole create user request, but the password now is going to be hashed. So we'll call await hash, and we pass in the value we wish to hash, which is the password, and we also provide a salt, which is just a series of random characters added on to make it a bit harder to decrypt. The other thing we want to address is we don't want to return the password itself to our callers, whether that be other services in our system or out the outside world using the API directly. So in order to get around this, we're going to introduce the idea of a separate response entity. So in our DTO folder, I'll create a new folder for requests. I'll move our existing request into there, and VS Code should auto update the imports. But we're also going to create another folder for response. So we'll actually create a user response.dto. And this is just going to be an interface called user response. And it's going to have an ID of type string. It's still going to have an email, but it's not going to have a password because we don't want to expose that to the outside world. So now in our user service, we will say we're going to return a user's response. And we need a way to build this response up from a user that we already have. So we can create a new method called build response, a private method. It'll take in a user, which comes from the database, and we simply want to transform that into something that we return to callers. So we can pass it the ID by extracting the ID field from the user and then calling to-hex string. And then the email, of course, it already exists right on the user. So now instead of returning the user directly, we can await this call here from the database, and then we can return this .build response and pass in the user. So now we can actually go into our user's controller, and we can specify that we're returning a user response here instead of any. And now if we test out our API again and we try to insert another user, we can see that we get back a user response which includes just the ID and the email and not the password, which is good to see. And additionally, if we look in our collection here, the password is no longer stored in plain text, but it's now a hashed value with a salt added. So there's one last bit of validation we need to build around inserting a user into our system, and that is ensuring that when we create a user, that a user with that same email doesn't already exist. And this is important because, as we'll see how we perform authentication later, we need unique emails. So in order to accomplish this, we'll add a new method in our users repository that will allow us to find a single user by their email. So we will return a user, and we will just return this .user .find one here, and we're just going to pass in the email. Now in our user service, before we create the user, I want to validate the create user request. So we can have a new method here called validate create user request, and this will of course take in the create user request. And the return type is simply a void. So what we want to do is we want to check to see if the user already exists with this email. So we'll reach out to our users repository. We'll call find one by email, pass in the create user request.email. And now we can say if the user does in fact exist, then we will throw a new bad request exception and say this email already exists in our create user method before we actually persist the request. So let's test this out briefly. If we try to add a user with the same email, we get that error. If we change the email, we now are able to persist the user. Okay, so now we need a way to actually submit requests to our backend from our UI in order to actually create a new user. So to do that, I'm going to create a new folder in our source directory called APIs, where we will keep our API related code, and we can start off by creating a users.api. So now we can export a const called users API, and we are going to call create API. And create API is going to be imported from Redux.js Toolkit, and we will also need another function there called fetch base query in a little bit. So create API takes an object, and we specify the path at which we want the reducer to live in our store. So we'll just call it users API, and then we're going to build a base query which just sets some defaults for all of the queries that we end up defining, queries or mutations that we end up defining in this API. So for example, we can specify the base URL for this API. Now typically in this base URL, this is where we would specify the URL for which our server is currently running at. So we know that's 3002, and then we could specify the endpoint /users. However, I don't want to do this because then I have to deal with cross-origin resource sharing or CORS, and also then we have to swap out this URL depending on where we're running the app, locally or in production. So really what I want to do is just to be able to specify /users, and in fact I want my API and my UI to both be running on the same base URL. In order to accomplish this, we're going to open up the package.json in our UI application, and we're going to add another property here called proxy and set it equal to our localhost backend running at port 3002. So if your port is running on a different port for your backend, make sure you update that here. And what this is going to do is it's going to proxy all requests we make when we don't specify a URL to this backend server here. Now we can go ahead and specify the endpoints that are part of this URL. And in this case, we only have one right now. We want to be able to create a user. So we're going to get access to the build parameter here, and then we're going to create or return a new object which has the name of the React hooks that we want to be able to expose. So in this case, we'll have create user, and then we can call build.mutation. Then we can give it the result type or the return type that we expect. So let's go ahead and define this right now. We can create a models folder, and we will create a user.ts. And this will be the same shape of the user response that we created in the backend. So we can actually just copy this response here and export it here as a user. So now we can specify the return type. We're going to get a user back after we create it. And then we can specify the type of the arguments for this function. So in this case, we can actually create a new folder called DTO. And now we can place our requests in here. So let's go ahead and create user request.dto. And we can simply export an interface here called create user request that takes the email and password which we need to send to the server. So now back in the users API, we can specify this was a create user request here, and make sure we import that properly. And then now this is going to take another object where we actually specify the query itself. So even though it's a mutation, we call it a query here, and we get access to the create user request. So this is going to be a function that returns URL. So in this case, it's going to be a post request to the base URL we've already specified. So we want to have a root URL here. We can specify the type or the method here. And then lastly, we'll want to include the create user request as part of our body. Now finally, let's go ahead and actually export this. And if we set it equal to the users API, we should get some type information where we can actually export the create user mutation. Finally, to be able to have this information saved in our store and to have Redux Toolkit cache this data, we need to open up our store file. And in the store, we can create a new reducer here where we'll specify the user's API dot reducer path and set it equal to the user's API dot reducer. Additionally, to take advantage of caching, we can specify the middleware for this API. So this is going to return get default middleware, and then we're simply going to call that function that Redux Toolkit exposes to us, and then we can concatenate the middleware from the user's API. So access the user's API dot middleware. So now we've added the user's API to our store. We can use it inside of our components. So now back in our signup form component, let's go ahead and get access to the create user function. We just structure it from the array and then call use create user mutation. So recall this is the name of the function that we've exposed here as an endpoint, create user. And now in our handle signup function, let's make this an asynchronous method. And then we can call await create user, and let's pass in the email and password, which we know exist because we've already done some validation here. So now if we go ahead and open our application up at port 3000 localhost and we go to the sign up URL, we can type in any email and password, click sign up, and we can see we have a successful post request here to our API backend. Furthermore, if we preview the response from the backend, we can see we have the newly created user that got returned to us. So now we can successfully create new users using our input form here. Let's go ahead and start working on our authentication in the app so that we can log in, authenticate ourselves with our backend, and actually get some useful information to build up a dashboard. So in order to implement authentication in our app, we are going to use a JSON web token approach. So our backend will authenticate the user with their credentials and then issue them a JSON web token that they can use to then make further requests. So we need to install a few more libraries here. So make sure we add Nest.js passport, and then passport local. We're also going to go ahead and add the types here for passport local and make sure that's a development dependency. Alright, so after we've installed these packages in our source directory in our backend, I'm going to create a new folder called Auth, and this is where we'll host all of our authentication code. Then I'll go ahead and actually have Nest.js generate us a new controller. So we can do Nest generate controller auth. So we get an auth controller created here. Make sure to spell this correctly here, controller. And let's also add auth service. So in our auth controller, we're going to go ahead and add a route so users can correctly log in to the app. Firstly, let's go ahead and inject the auth service, which we'll use to actually log the user in. So we have the auth service here, and now let's add a post route called login, and this is an async login method here. We're going to say this is a void return type, and now before we reach this login method here, we want Nest.js to execute what we call strategy using passport, which is essentially just a way to authenticate using different forms of credentials. In this case, we want to perform authentication with a username and password. So let's do just that. I'm going to go ahead and create a new folder in auth called strategies, and then I'm going to go ahead and create a local strategy here. So this is going to be an injectable so that we can inject it, and it's going to be called local strategy, and it's going to extend passport strategy from Nest.js passport. We're going to go ahead and pass it in a strategy, and this strategy is going to come from passport local. So you can use different strategies. It doesn't have to be passport local, but this one allows us to use username and password as credentials. Next, we specify a constructor, and I'm going to go ahead and inject the user service in here because we will need it to validate the user shortly. Additionally, we're going to go ahead and make a call to the super here, and here we can specify different arguments. In our case, we're going to specify the username field, because we want the username field to actually be the email itself and not username. When users log into our app, they're going to use their email. Next, we need an async validate method, which the strategy will call by default when we use this. So we need to be able to validate the user, and this method is going to be provided the email and the password from the incoming request. Then we're going to return a promise, and we're going to return the user response. So now let's actually make a call to the user service so that we can validate the user and get the user back if it is valid. So let's go ahead and enter our user service, and I'm going to create a new async validate user method in here. that obviously takes the email that we just had. So we'll take the email and the password, and similarly this will return a promise of user response. Okay, and then we're going to check, okay, does this user exist by email? So let's reach out to the user's repository, find one by email, and then pass in the email. We can quickly check if the user did not exist, then right away we know we can throw a not found exception because the user does not exist. And we'll say user does not exist by email. And then let's provide the email just to make this a more friendly error message. So we know that the user exists. Next, we need to make sure that the password is valid. And to do this, we're going to use the bcrypt library because if you remember, our passwords are stored as hashed values in our database. So bcrypt has another method called compare that lets you compare the hashed value against a plain text value. So what we'll do is we'll create a new const called password is valid, and this will be equal to await compare, and then we pass in the plain text password as well as the hashed password. And what this will do is it will return true, the password are equal, and if not, it will return false. So we'll say if password is not valid, then we'll throw an unauthorized exception and say credentials are invalid. Lastly, we know that the user is valid at this point, so we'll return this.build response and send in the user. So now we have all the logic we need for the local strategy to take advantage of this. So we can simply return this.userService.validate user, pass in the email and the password. So finally, to be able to use this strategy, we're going to need to implement a guard so that we can use it in our controllers. So I'll create a local auth guard in our guards folder I've just created in our auth directory. And this will simply be a class called local auth guard that extends auth guard from Nest.js Passport. And we will provide the name of the strategy that we are using as a string. So in this case, it's local. So lastly, when we return the user from the validate method here, Passport will actually attach the return value of this method to the incoming request so that it's available downstream later on in our application. So to be able to extract this user from the request, let's go ahead and quickly create a decorator that will allow us to do that. I'll create a current user.decorator. So let's create a const called get current user by context. This will have access to the context, which is the execution context from Nest.js Common, and this will return a user response. And we will return context dot switch to HTTP because this is an HTTP decorator, and we'll call get request to get access to the request. Lastly, we can then pull the user off that Passport has added for us. Okay, now we can actually expose this functionality by exporting a const called current user, and then we'll use the method create param decorator from Nest.js Common. This takes a function that takes two parameters, the data, which we will not need to use, so we can prefix it with an underscore, and then we need the context here, which is the execution context. We can simply return the method we just created, get current user by context, and then pass in the context. So this is what our decorator looks like. So let's take advantage of this new strategy and decorator. If we go back into our auth controller here, we can now decorate the controller with use guards from Nest.js Common and then pass in the local auth guard. Additionally, we can use the decorator we've created, current user, to get access to the user, and we know this is going to be a user response here. We're also going to get access to the response object here from Nest.js and add pass through to true so that Nest.js still goes through its request response lifecycle. So this will be the response, and the response is from Express here. So now I'm going to call await this.auth service.login, pass the user and the response, and we'll implement this shortly. And then lastly, after the user's logged in, I want to send the response the user, so that the client, after we've logged in, gets the user back. So before we implement the login method, I realized we need to actually create an auth module itself here, because we didn't already have one. So in our app module, let's remove the auth controller from here and the auth service from here, because we want to extract this into its own module. So in our auth module, I'll just copy the app module we already have, change this to auth module, and now we can add our auth controller in here, and then the providers array will have the auth service as well as the local strategy. And finally, if you recall, we actually used the user service in our local strategy, so we need to import the users module, and in our users module, make sure we export the user service here. So in our auth service, let's go ahead and start implementing that login method. And we know it gets access to the user response and then the response object from Express. The reason why we need access to the response object is because we're not going to return the JSON web token directly to our client and have the UI set it in local storage, as you typically do see in some apps. The reason why we're not going to do that is because we're going to use cookies instead, specifically HTTP only cookies, which are far more secure than storing tokens in local storage in the browser. The reason for this is because local storage is susceptible to cross-site attacks, so hackers could potentially execute JavaScript on the client, get access to the token, and then the user's credentials are essentially exposed. So with HTTP only cookies, we only send the access token as a cookie when we communicate via HTTP requests, and the token itself isn't accessible using JavaScript. So before we implement our login method, we need to set up the JSON Web Token module from Nest.js, and specifically we need to provide a JWT secret value that will be compared against in our backend. So to do this, in our M file, we'll create a JWT secret, and this is a value that we need to keep hidden, which is why we're keeping it in the M file. So this can be any long random string that you do not want to expose to the outside world. We're also going to provide a JWT expiration time here as an environment variable so that we can change this. This will be how long our web tokens are valid for before they need to be refreshed. And now we can go back into our auth module here, and we're going to need to, of course, actually install the Nest.js JWT library. So make sure we yarn add Nest.js JWT and passport JWT, as we'll need to implement a new strategy to work with the JSON web token from the cookie that's included in the incoming request. So make sure we also add development dependency types / passport JWT. Now we can include the JWT module using register async. We're going to use useFactory here, similarly to how we've instantiated our MongoDB. We'll inject the config service here, and we will return an object. So this takes the secret. They need to provide the secret value it's going to use to check incoming tokens, and also use this value to sign tokens. So we'll call config service.get. It's a string, and we know it's called JWT secret. Now we can also provide sign options here and specify the expires in value. So this is going to be config service.get, and we'll call JWT expiration time, and make sure we provide S here at the end to specify that this is a value in seconds. Finally, make sure we actually inject the config service here. So firstly, we're going to need to specify our token payload, which will be a type that we can define up here. Let's do just that. We will have an interface called token payload, and this is what the token we sign will look like after it's decoded. So we want to include the user ID in the token. The token payload is type token payload, and we'll just simply include the user, so we have access to the user ID. Next, we'll specify an expiration date. So we'll have a new date here, and then we can call expires.setSecond. We'll call expires.getSeconds to get the current amount of seconds, and then add on the amount from our environment variable. So to do that, we'll have to inject the config service here. So now we can add on this.config service.get and call JWT expiration time. So this will be the amount of time in which the token expires. Lastly, we will actually create the token. So to do this, we'll need to inject the JWT service that Nest.js offers us. So let's inject the JWT service here in our constructor, and now we can actually sign the token payload that we've created. So we'll call this.jwt service.sign and then pass in the token payload. So now we're ready to actually set the cookie on the response. So we'll call response.set response.cookie, and we can name this whatever we'd like. We'll call this authentication. So this is the authentication cookie. We will actually provide the token here. So remember, this is just a signed string. And then we're going to provide some options to the cookie. We're going to say HTTP only, so that it's only a cookie set during HTTP requests, and it's not accessible in the browser or using JavaScript. And we can set our expires value here so that it matches when our token expires. So before we test out our login functionality, make sure we actually add our auth module to our root module, app module here. So now in Postman, if I send a post request to localhost 3002, which is where my auth or my Nest.js server is listening, to auth login, and I have my credentials here after I've created an account with this username and password, or email and password, and we send the request, we can see we're getting the user sent back, but also if we look at the cookies section, we're getting our authentication cookie set. And additionally, if we tried a different username that didn't exist, or for example, a password that was invalid, we can see our authentication is working properly. So our next step is to actually use this login functionality in our UI. So in our APIs folder, under our React app, I'll create a new API called auth.api.ts. And if you notice, this corresponds very closely, if not exactly, to our backend API structure, which is quite useful. So we will export a const here as we've done before, called Auth API. And as you recall, we use create API. We specify a reducer path. So this will be called Auth API. We'll have a base query here. We'll call fetch base query because we will specify the base URL as /auth, because remember we're using our proxy as we set up, and we can then have a section of endpoints. We will get access to the build parameter, and then we can specify our login endpoint. We'll call build.mutation because it is a post request. And of course, then we specify the result. We know we get back a user, and the request itself we'll have to create here. So we'll have a login request.dto, and this is actually going to be just the same as create user request. So we can copy that and just change the name. It might not be the same, so it's nice to keep two separate interfaces. So we have the login request, and then we of course have the object itself. So make sure we import this. And now in the object, we specify the query function. As we saw, we get access to the login request. And now we can specify the URL, which we know is /login. We know it's a post request. And lastly, the body we pass is the login request. So finally, we are going to export the mutation from the Auth API. And lastly, you can see here we have a problem exporting the mutation, and that's because my import up here is incorrect. We don't want to import from dist, but instead this should be query, and then from React. And now, as we've done before, we'll have to add this new API to our store so that the data is persisted and we can cache it. So we'll have the auth API.reducer path set here, auth API.reducer, and we'll do the same procedure with attaching the middleware here. So we can actually just concat the auth API.middleware. So now that we've set up our auth API, we can actually use it inside of our components. Let's do that. In our login component, our login form component, we can get access to the use login mutation here. And our handle login function, make sure we've changed it to be asynchronous, and then we can simply call await login with the email and password that we've already validated against here. So back in the browser at localhost 3000/login, on our login form now, if we provide a valid email and password and log in, we can see we get a successful response back with the user. But more importantly, we can see that our authentication cookie was properly set. So now that we've actually authenticated, we need a way to tell the rest of our Redux application that we are in fact in an authenticated state. So to do this, we're going to set up a new auth slice, which is a new set of state in our Redux app. So let's go ahead and set up a piece of state in our Redux store that allows us to determine if the user is currently authenticated in our app or not. So I'm going to create a new folder here called slices. And in Redux Toolkit, a slice is simply a piece of state with a reducer and a set of actions that are automatically created for us. So it reduces a lot of the boilerplate that you typically have to go through when working with Redux. So I'm going to create an auth slice, and we're going to create our slice here. Const slice is equal to create slice from Redux Toolkit. And now we provide a name which will correspond to the path in our store. So we'll give it a name of auth here. And then we'll provide an initial state. So for our initial state, I want to provide a type. So let's define an interface called auth state here. And this is what the auth state in our app will look like. Normally we would keep the access token and a refresh token in this auth state, but because we're storing this as a cross-site cookie or access token, we don't need to store it in memory anymore, and we can simply just add a user here if we are authenticated. So let's set our initial state as auth state, and then we'll provide some reducers here. I'll have a reducer here called set auth state, which takes in the current state, and then we'll extract a payload which we know will contain a user. So this is going to be of type payload action, a type that we can infer of being auth state. And then, so make sure we import payload action from Redux.js Toolkit. And now let's actually go ahead and set the user on the state object. And we're not actually mutating the state it's directly here, because under the hood, Redux Toolkit is using a library called immer, which allows us to use immutable objects, but still mutate them. Then I'm going to go ahead and export our set auth state from the slice.actions here. I'm going to export by default to slice.reducer. And lastly, I'm going to export a const select current user, which will simply be a helper method that takes the current state or the root state that we import from our app store, and it returns the state.auth, which doesn't exist yet because we haven't hooked it up to our store, and then the user itself. Go ahead and open up store.ts, and we will import auth from our slices /auth.slice. And all we have to do now is add auth to our configure store here. And now we can use this newly created slice. So let's do that by going back into our login form. And here, instead of just logging in, we're actually going to extract the response we get here from the login. And we need to provide a cast here to make TypeScript a bit happier. We are going to convert this as data user. So we know that this is a successful response. We're going to wrap this in a try catch block. So if this response fails and we weren't able to log in for some reason, for now we'll just log the error. But if it did succeed, then we know that we've gotten the data back, and we know that data is a user. So we can dispatch our setAuth state action. So to get access to the dispatch method, we can up here use const dispatch is equal to use app dispatch from our hooks. So now we'll go ahead and call dispatch setAuth state, and the user will be equal to the response.data. And finally, make sure we actually import the user here from the models folder. So now after we log in, we're successfully setting the user in our application and letting all of our other components know that we are authenticated. So we want to be able to redirect the user to our home page after they have been authenticated. So let's go ahead and create a new page. This will be our home page. So home.page.tsx, and this is going to be in our pages directory. So we can just copy our boilerplate React setup here, and we'll be home page. And for now, we will not return any JSX here. We'll just use an empty tag. Get rid of this unused import, and we'll export the home page. So every time we add a new page, we'll need to update our routes here. We will add a new route for path, just slash, because this is the root path, and the element here will of course be the home page. So now we should be able to navigate after we've logged the user in. In our login form, we can get access to the navigate method using use navigate from React Router, and make sure we properly import React Router. So import navigate, import use navigate from React Router. Now after we dispatch the event to log the user in, we can simply navigate to our home page. So to test this out, I'm on my login page here at localhost 3000, and after I successfully log in, you can see we've been redirected to our home page, which of course has nothing on it yet. So this is good. However, we want to be able to protect the home page so that if the user isn't logged in, they can't access this page or any other page in our application without being properly authenticated. So let's go ahead and implement that now. So we need to implement protected routes so that if a user is not authenticated, they can't access certain pages on our application. So in our routes directory, I'm going to create a new component called protected route.component.tsx. I'll have to import React from React, and then we'll have const protected route, which I'm going to have any for the props that we take here. And we're going to get access to the children because we're going to see how we use this component in a second. It's going to be wrapped around our existing elements in our routes. So we can return a component here. So in our protected route, we need to check in our app to see if we are authenticated. And of course, we can do this by using the helper selector that we've already created to select the current user. So I'm going to call use app selector from app hooks, which of course is a function that gets access to the state, and then we can extract what we want from the state. But of course, we're going to use the select current user method, helper method we created. All we have to do is pass in the state, and now if the user exists, we'll get access to it, or if it's not authenticated, then this will be undefined. So we'll say if the user exists and we're authenticated, simply return the children components. Otherwise, we're going to navigate, so import this component from React Router to /login. So now we can export the protected route here. So now we can go back into our routes component here, and instead of simply returning the home page, we're going to wrap this inside of our protected route component that we just created, and then we can supply the home page as the children component here. So now if we go back to our application here and we try refreshing and going straight to the home page, we get redirected to the login screen. After we log in, we can now access the home page. So now we've implemented this login capability in our login form. We need to do the same thing for our sign up form, so that if the user signs up, they are also authenticated and we can redirect them appropriately. So this flow is going to be very similar to the one in our login form. We need to get access to the login function here from use login mutation. We'll need to be able to navigate, so we can import this from React Router and call use navigate. And then lastly, we'll need to dispatch. So dispatch equal to use app dispatch. And make sure we import this appropriately. We'll have to import use navigate manually here. So after we create the user, we want to immediately log the user in. So we will get the response after we call await login, pass the email and password, and this will be as data user. And because we're casting this here, we want to wrap this whole thing in a try catch to make sure it didn't in fact succeed. We just want a console error. Otherwise, we'll continue along here and dispatch and set auth state event based off of the response that we received. So the user will be the response.data. And lastly, we can navigate the user to the home page. Make sure we import the user here as well. So similarly to our login page, after we sign up here, we should be redirected to the home page. So now that we're successfully authenticating our app, let's start actually building out our crypto dashboard. So we're going to use Coinbase as the cryptocurrency API in this project. And in order to use Coinbase, we're going to need to follow their Auth API flow to authenticate the user and get access tokens to be able to make API requests on their behalf. So before we go ahead and start building out our cryptocurrency dashboard, we need to actually validate the authentication cookie that we're setting for the user in our backend, so that we can protect our routes and get information about the user based off of this cookie. So to do that, we're going to need a new package here called cookie parser. So make sure you add yarn add cookie parser, and let's also add the types here. So yarn add -d type/cookie parser. So Nest.js will automatically parse incoming cookies for us if we go ahead and in our main.ts we call app.use cookie parser. And this function is from the cookie parser library. And make sure we actually import star as cookie parser here before we use it here in our bootstrap method. So now we can parse these incoming cookies. So in our strategies, we're going to create a JWT or JSON Web Token strategy. So this class will be an injectable and it'll be called JWT strategy. It's going to extend passport strategy, and we're going to pass in the strategy, and of course make sure that this strategy is coming from passport JWT and not passport local. Now in our constructor, we're going to need to inject the config service, as well as the user service, because we're going to need to supply the request with the user after we ensure that the user does actually exist. So we'll need to get the user service here, and also make sure this is injectable here, and we get rid of this unnecessary import. So in our constructor, we're going to make a super call here and pass in an object, and we're going to pass in JWT from request. Okay, and then we're going to call extract JWT dot from extractors, and then pass in an array here. This array is going to contain a function, and we're going to get an argument here that will be the request itself. The request is from express, and we're going to return here the request Nest.cookies.authentication. So we're actually pulling the authentication cookie off of the request here and telling the JWT strategy use this as the source of truth for our JSON Web Token. Lastly, we're going to need to provide the secret or key. So we'll call config service.get and JWT secret. So this is where we actually validate that this token is correct. Finally, we're going to need our async validate method here. This gets the token payload, or the decoded JSON Web Token. So we get the token payload here, and the token payload is what we defined in the auth service. So make sure we export this so we can import it here. And we're going to return a promise. This will be the user response. So now that we have the token payload, we need to be able to reach out to our user service and get the user by ID. So let's go ahead and add that functionality to our user service here. So we'll add a new async method, called getUserById. This will take the user ID, which will be a string, and we'll return a user response here. So we're going to reach out to our users repository and call users repository find1. We're going to need to actually implement this in the users repository as well. Async find one by ID. We get the user ID, which is a string. Return the user, and we can return this dot user dot find by ID, and simply pass in the user ID. So now back in our user service, we can use this function from the repository, pass in the user ID, and we'll make a check to see if the user does exist. So if the user didn't exist, so if the user does not exist, we're going to throw a new not found exception and say user not found by ID, and then we'll pass in the user ID just to make this a more friendly error message. So finally, we will return this dot build response and pass the user. So now the JWT strategy can call this dot user service dot find dot get user by ID, and we'll pass in the payload dot user ID. So now if the JSON Web Token was valid, this validate method here will populate the request with a user, which we can use later on in our controllers with the get current user decorator. Now finally, make sure we open up our auth module and provide the JWT strategy as a provider here so that Nest knows about it. So now that we have that strategy, we're going to need to create a JWT auth guard as well, like we've done for the local auth guard. Copy this local auth guard into here and change it to JWT auth guard, and instead of local here now, this will be JWT. So now we can correctly protect our routes in our application to ensure they have that authentication cookie and also populate the user for a given request. So before we go ahead and integrate the Coinbase API, we're going to need to register the application on the Coinbase website. So head to coinbase.com/settings/API and create a new OAuth 2 application using this button here. You can name it whatever you want, but there's a couple of important things we need here. For one, we need to add a permitted redirect URI. Okay, and this should be localhost 3000 whichever port your server is running on. So my port's running on 3002 from our backend, and then we can add the route that we'll use for the callback. So add Coinbase Auth callback and make sure you save that. Lastly, we're going to need to take the client ID and the client secret that they provide us here and put this into our .m file in our backend so that we can use it and interact with the API. So add a Coinbase client ID here, paste that into the .env, and then do the same thing for the client secret. So add the Coinbase client secret and paste that in there. So we're also going to add the Coinbase redirect URI as an environment variable, because this will be different when our application is running in production, and we want to be able to swap that out at runtime. So for now, this will be where our application is running on the back end, so port 3002, Coinbase Auth callback. So this is the callback URL that our authentication flow will use. So now we can actually start building our connection to the Coinbase API. So the first step in this process is authenticating the user with Coinbase. So in our auth folder, I'm going to create a new Coinbase folder, and then I'll go ahead and create a new Coinbase module. And here we can export class Coinbase module, and we'll decorate it with the Nest.js module decorator. And then we can go ahead and create a new Coinbase controller. So this will be a controller with the name Coinbase, and we'll export a class called Coinbase controller. So we're going to create a new get route here, and this will be called auth, and we will call this authorize, and we're going to need access to the response here from Nest.js common. So let's get access to the response, and this is going to be of type response from Express. The return type is going to be void, and additionally we want to protect this route with our JWT auth guard that we set up earlier, so that we need an authentication cookie in order to process this route and that the user is in fact logged in. So now that we have this authorized route, we can add our controller to our Coinbase module here. We'll add Coinbase controller, and I'm also going to move the Coinbase folder out of the auth folder and move it directly into the source directory, because there's going to be routes beyond just authentication in this Coinbase folder. So now we can also open our app module and then add the Coinbase module as an import here. So we're going to need a service to authenticate and authorize from our authorized route here. So I'm going to create a new service called Coinbase Auth Service.ts, which will be handle all authentication around Coinbase. So I'll have Coinbase Auth Service, and we'll have our public authorize function here that takes the response from Express. It has a void return type. Now we're going to need to go ahead and build the URL to the authorized endpoint from Coinbase. So I'm going to create a private build authorize URL, and let's build this URL up. So we'll create a new const called authorize URL. There'll be a new URL. So this is the URL that Coinbase offers us for their OAuth authentication flow. It's coinbase.com/OAuth/authorize. So now we're going to append a lot of search params to this URL here. So we can call search params.append. And if we look at the Coinbase OAuth documentation, which I'll include in the description, we need to include the response type for this authorized call. So in this case, it's always going to be response type code, because it's going to give us an auth code as the response. Then we're also going to append the client ID. So we'll add client ID, and to get the client ID, we're going to need to get access to our config service, as we've injected this as an environment variable. So we'll add the config service here, and we'll call this .config service.get Coinbase client ID. Next, we'll add the callback URL so that the authentication flow knows where to redirect our request. So we'll add redirect URI, and then call this config service.get Coinbase redirect URI. Finally, we're going to need to add some scopes to the request here, which are essentially just the permissions that we're requesting from the user to be able to use on their behalf. So we're going to need to add wallet transactions read and wallet accounts read, so that we can get access to the accounts and the transactions on the account. And notice these are separated by a comma here. So now that we've correctly built this URL, we can return the authorized URL. In our authorized call, we're simply going to call res.redirect. So we're going to redirect the response to the authorized URL that we've just built, and we'll pull the href off of this URL. So then we can simply return from this method. And now in our Coinbase controller, we can inject the Coinbase auth service so that we can use this in our route down below. So we'll call this.Coinbase auth service.authorize and then pass in the response. And make sure in our Coinbase module, we add the Coinbase auth service as the provider. So after the user authorizes our application, Coinbase will redirect to the URI we specified here. So we need to add that and handle the call appropriately. So we'll add the auth callback here, and we'll also decorate this with the use guard, JWT auth guard, so it's a protected route, and we'll add a method handle callback. So we're going to need access to the request itself, as well as the response here. So this is the response from Express. The return type is void, and then we're going to add a new method in our Coinbase auth service to handle the callback. So I'll add a new public handle callback here, and of course we get the request from Express and then the response from request, return type void. So on the request itself, we can destructure the code from the request.query. So after the authorized URL redirects us to this route, it's going to add an authorization code as a query param, which we can then use to make another call to Coinbase to get access tokens. So we're also going to extract the user from the requests, which we know is populated from our JWT auth guard flow here and our JWT auth strategy. So I'm going to add a new private method here called get tokens from code. So we're going to take the auth code here, and then we're going to reach out to the Coinbase tokens API and exchange the auth code for a set of tokens that we can use to actually make calls. So to make external HTTP calls, so to handle external HTTP calls, we're going to need to add the Nest.js Axios library. So let's add Nest.js/Axios, and then we can add to our imports array the HTTP module from Nest.js Axios. So now back in our Coinbase auth service, I'm going to go ahead and also inject the HTTP service, and this is coming from Nest.js Axios as well. So now in get tokens from code, I'm going to return this.http service.post, and I'm going to provide the HTTPS. I'm going to provide the api.coinbase.com/oauth/token endpoint, and now we provide a body here with some parameters. So the grant type is going to be authorization code, because this is an auth code flow. We're going to provide the code itself, which we have as a parameter here. And then we're going to need the client ID, which we know we can get from the config service, Coinbase client ID. And then we'll need the client secret as well, which we can also get from the config service. Lastly, we'll also need the redirect URI. This is just a security measure to make sure it matches the flow that we're already going through. So now this request should succeed and we should get some tokens back. So back in our handle callback, I'm going to call this.getTokens from code, provide the code as a string, and then I'm going to subscribe to this call because this is an observable, and then we should be getting back the tokens response. So I'm going to provide an async method here called tokens response as the parameter. So now we're getting these tokens back. We want to save them in our database so that we can make calls without having the user to re-authenticate every time. Now we don't want to store the tokens directly in plain text because this is insecure, and if an attacker were to gain access to our database, we don't want to expose the tokens directly. So we need a way to encrypt these tokens and then also decrypt them when we take them out of the database. So we can't use bcrypt for this because bcrypt only hashes values one way. We need a mechanism that will hash values and also unhash them. So I'm going to create a new encryption service in our auth directory that will handle this task. This is going to be an injectable, and we'll export the encryption service. So we're going to have two methods here. The first one will be encrypt, which will take the data to encrypt, which will be a string, and we're just going to return the encrypted string. Now we're going to need access to the config service. So make sure we inject that. And lastly, we're going to need to specify the algorithm we're going to use to encrypt our data. So I'm going to specify a read-only property here called algorithm and set it equal to AES256, which will be our encryption algorithm. Now, first thing we need to do is, now we're going to use the crypto library from Node.js. So import star as crypto from crypto. Encrypting and decrypting is a bit complex, but we'll walk through it here. So the first thing we need to do is get a set of random bytes from the crypto library. And then we need to create a cipher. So we're going to do that by calling crypto create cipher IV. So we're going to pass in the algorithm we're using. We're going to pass in a buffer, and this buffer we're going to concatenate a buffer from, and then we're going to get the encryption key. So this config service.get, and now we need to specify an encryption key in our end file. So open up the .m file and specify a new property here called encryption key, and this can be any value, a long random set of characters. So now back in our algorithm here, we're going to specify we need the encryption key from the config service, and then we're also going to specify buffer.alloc, and we're going to allocate 32, and then finally we're going to provide a total length of 32 here, and then we will pass in the random bytes that we've created. So in total, this is what the cipher looks like. Now I'm going to create a new let called encrypted and set it equal to cipher.update and pass in the data we want to encrypt. Then we're going to set encrypted equal to buffer.concat, pass in an array. We're going to pass in the encrypted value, and then we're going to pass in cipher.final and make sure we call this as it's a function. So lastly, as our return value, we're going to return a string here, and then we're going to return iv.toString, pass in hex as the encoding. Then we're going to pass in a colon and then call encrypted.toString hex. So this is our final algorithm to generate an encrypted string. Now let's go ahead and implement the decrypt method. So this will take a piece of data that is encrypted, and then we're going to return the decrypted value. So we're going to need to get the text parts first. So we're going to split the encrypted piece of data at the colon, and then we're going to create an IV, set it equal to buffer.from, call textparts.shift, and then provide hex as our second argument. Next, for encrypted text, we're going to set that equal to buffer.from textparts.join, and then we're going to provide the colon here, and our second argument will be hex. Finally, we need to create the decipher now, which will be crypto.create decipher IV. We'll pass in our algorithm, and then we'll call buffer.concat as we've done before, pass in buffer.from, and then pass in the encryption key from our config service. Then we'll do the same thing, called buffer.alloc 32, and then our last argument here will be 32, and then we'll pass in the IV argument. Then we'll create a new let called decrypted, set it equal to decipher.update, pass in the encrypted text, and then we'll set decrypted equal to buffer.concat, pass in decrypted, and then call decipher.final. So then lastly, we can simply return decrypted.toString, and now this is our implementation for decrypting an encrypted value. So let's go back into our auth module and specify this encryption service here as a provider, and then we'll also have to provide it as an export, so encryption service. Now our Coinbase module, we can import the auth module. So we now have the tokens and a way to encrypt them. We now need a way to update our user in the database with these tokens we have. So to do that, I'm going to expand on the model definition we have for the user in the database right now. I'm going to add a new property called Coinbase Auth, which will be a new object that we're going to create, and it's going to be optional because it won't exist when the user is created. But I'm going to create a separate model here called Coinbase Auth.ts. So I'm going to create a separate model called Coinbase Auth.ts. And this will simply be a class called Coinbase Auth, which will host a new set of properties. So we'll have the access token saved here. We're going to save the refresh token from Coinbase. And then we're going to save the expiration date. So when this token expires as a date. So now we can go back to the user model and specify Coinbase Auth here as a new property. So we're also going to need a way to update the existing user with this auth property. So in our user service, I'll create a new function called update user that will take the user ID as a string and then the data to update with, which will be a partial of the existing user definition, and will of course return the newly updated user. So we'll have to also provide this functionality in our users repository. So I'll create an async update one. We'll get the user ID as a string, and similarly the data here will be a partial of an existing user. So we'll return a promise of the newly updated user, and then we'll call this user find by ID and update. So we can pass in the user ID, the data we want to update with, and then an options object where we're going to specify new set to true, which tells Mongoose to give us the newly updated document. So we can take advantage of this new method by calling await this.users repository update one. We'll pass in the user ID and the data we need to update with. Then we'll check to see if the user wasn't returned. Well, then we know the update didn't take place. So we can return a not found exception and say user not found by ID, and then we'll specify the ID, user ID here. Lastly, we'll return this.build response and then pass the user. So let's head back to our Coinbase Auth service, and I want to create a new method that is going to handle the user update. So I'll create an async method called update user Coinbase Auth. It's going to take the token payload as the first argument, and then the user ID as the second argument here. So on this token payload or the token response, we know that we're going to get back an access token here, and I'm going to destructure it like this. So it's refresh token, and then I'm going to set this equal to refresh token here. And then we also get an expires in property. So this is all going to be set equal to token payload. So we have this information coming from Coinbase as the response after we hit the token endpoint. Now we need to create an expiration date. So I'm going to create a new date here, and then I'm going to call expires.setSeconds. And this expires in property, if we look at the Coinbase docs, is in seconds. So I want to call setSeconds on this new date and call expires.getSeconds plus expires in, which is coming from Coinbase to tell us when this token expires. So now we have these three properties that we need to update the user. I'm going to actually inject user service, so we can do just that. I'll add the user service here, and of course we'll also need to make sure that we properly import the users module to take advantage of the user service. Make sure we import the users module, and now we can call this.user service update user, pass in the user ID, and now we can specify the Coinbase Auth property, which is what we want to update. We can pass in the access token, refresh token, and then the expires property. So to actually take advantage of the encryption service, we're going to need to inject it here. So we'll inject the encryption service, but before we set the access token, we're going to call this encryption service .encrypt and then pass in the access token here. And then we'll do the same thing for the refresh token. So this encryption service .encrypt and then pass in the refresh token. So now we should be saving encrypted tokens in the database. So now the user will be properly updated. So let's go back up here to our handle callback method. So I want to call await this update user Coinbase Auth. I'm going to pass in the tokens response data, which is the token payload. And then I'm going to pass in the user.id, which is coming from the request because of our JWT strategy. Now to make TypeScript happy here, I'm going to have to cast this to unknown first, and then as a user response here, and then make sure we wrap this. So now we're properly updating the user with the correct tokens from Coinbase. And the last step here is going to be to redirect the user back to our app. So since we have access to the response here, we can do just that. However, this redirect URL will be different depending on whether we're running locally or in production. So to make this value dynamic, we're going to update it in our env and add a auth redirect URI here. And I'm going to set it equal to HTTP localhost 3000, which is where our UI is running. So now back in the Coinbase auth service, I'm going to lastly call res.redirect and then pass this.config service.get. And then we can pass the auth redirect URI. Now, finally, coming back into our Coinbase controller, we can simply call this .coinbase auth service.handle callback, and then of course pass in the request and the response here. So now we have everything we need on our backend to support an OAuth flow with Coinbase. Let's go ahead and set things up on our UI to test it out. So now we can implement the Coinbase auth flow in our React app. So I'm going to open up our homepage again. And now in our homepage, I'm going to create a new div. And this is going to be a similar structure to our sign-in page where we're going to want to center everything. So I'm going to give this a class name of flex, justify center, item center, flex call, and then height screen to make sure everything's centered. And make sure we spell center here correctly. And then I'm going to include a button for material UI. I'm going to use the contained variant. I'm going to give it a size of large. And then we're going to have an on-click listener, which I'm going to call handle connect Coinbase, which we will implement in just a second. Then we're going to add a bit of text for a button and say connect Coinbase. So then we can add our click listener here. So now we want to redirect the user to our Coinbase auth URL in our backend to start the auth flow. So to do this, we need to know the URL of where our auth flow is listening at. So this can change dynamically based on the environment we're running in. So what I'm going to do is I'm going to create a .m file as we've done before in the backend. And now we can include a React app Coinbase auth URL and set it equal to where our server is running, 3002, and then Coinbase auth is the endpoint to start our auth flow. So make sure we prepend this env variable with React app, because this is how create React app will inject environment variables for us. So now we can check to see if process.m.react app Coinbase auth URL exists, and if it does, then we'll redirect the user using window.location.href equal to, and then we'll set it equal to the URL for our Coinbase auth. So now back in our app, after we log in, we should see the connect Coinbase button. If we go ahead and click through on this button, we get sent to the Coinbase authorization website, which asks us to authorize our app. So after we click authorize, we are redirected back. Now if we go ahead and open up our database crypto stats with the users collection here and go look for the user, we can see a Coinbase auth object was correctly created on this user, and we can see our access token and refresh tokens were saved with our encryption algorithm. You can see this is encrypted here. So we're going to need to create a simple route in our user's controller that is of course protected by the JWT auth guard, and it will be called get user. And all it's going to do is extract the current user from the request, which we've already pulled off using the JWT strategy, and it's just going to simply return that user right back to the client. So we're just going to return the user right back. So now we can go back into our UI, and under our users API, we can now add a new query called get user. This will be build.query, and it's going to, of course, return a user, and the arguments are undefined because we don't need any arguments. We're just going to need the authentication cookie for this route to work, and then we're going to add our query. So this query is going to be very simple. All it's going to be is just a URL at the root. So now we can correctly query the user from our server, essentially exchanging the auth cookie for the user. So now, to ensure that we make this call every time the app refreshes and we relog the user in, we're going to open our app component back up. And in our app component, we're going to get the data or the user from the use_get_user query here. And of course, make sure we actually export this from the user's API. So the use_get_user query. We're going to call the use_get_user query, and this is undefined because it doesn't take any parameters. Now we also want to get access to use_app_dispatch, so we can dispatch an action, and then we'll also need access to navigation from use_navigate from React Router DOM, and make sure we actually import use_navigate from React Router directly. So now we're going to create a new use_effect hook here, and every time the user, dispatch, or navigate changes, which should only be when the component first mounts, we want to check to see, okay, do we have a user? And if we do have a user, then let's dispatch the setAuth state action here, and of course pass in the user so that we're authenticated. And if we do get authenticated, let's navigate. Make sure we change this to navigate, and if we are authenticated, then we can navigate to our home page. So now in our application, if we try refreshing the page, we see the login screen very quickly, but then we're immediately redirected to our home screen here because we are in fact authenticated and we don't have to log back in. So now we're ready to actually reach out to the Coinbase API and get some useful information to display to our user. So I'm going to create a new service for this called Coinbase.service, and this will be an injectable class that we can export called Coinbase service. We'll want to, of course, include this in our providers array. And this Coinbase Auth service is going to need a couple of dependencies. We're firstly going to need the HTTP service so that we can actually reach out to Coinbase API. And then of course we're going to need the Coinbase Auth service to actually authenticate with the API. So Nest will inject these dependencies for us, and for this app, what we're going to return to the user is a list of their account transactions for their linked wallet. So I'll create a new method here called getPrimaryAccountTransactions. So by default, we're just going to get their primary account transactions. So for a given user ID, we will return a promise, and this will be a type any. So with the Coinbase API, the first step we have to do is actually get the primary account. So let's go ahead and implement that with a new method. This will be a private async method called getPrimaryAccount, which will take the user ID and return a promise of type any. So we're going to wrap this whole call in a try-catch block just so we can catch any errors that come back from the API. And we are going to get access to the response observable here, and then reach out to the HTTP service.get, and then we will call https://api.coinbase.com v2/accounts. So this is the endpoint for the accounts API. So now importantly, we need to add headers here, especially the authorization header, so that this authenticated call succeeds. So we need a way to inject our access token here. So in order to do that, we're going to implement a new method in our Coinbase Auth service. And this is going to be called getAccessToken, because there's a few checks we need to do before we retrieve the access token. Namely, we want to check to see if it's expired, and if it is, we refresh it using the refresh token. So this method will take the user ID, and it will return the access token as a string. So if we take a look at the user service, we have a function to get the user by ID, but remember this returns a user response, which is just the ID in the email. We definitely don't want to return the Coinbase auth back to the UI or any other clients, because that is sensitive information. So instead, what we're going to do is we're going to create a new method that is solely responsible for getting that Coinbase auth information. So we'll create a new method called get Coinbase auth for a given user ID. This will return the Coinbase auth model that we have. So we're going to reach out to this .users repository, call find one by ID with the user ID. We'll make our usual check to see if the user was not found. Then we turn a not found exception and say user not found by ID, pass in the user ID. So now we can also check to see if the user.coinbase auth was not included. Then I'm going to throw a unauthorized exception and say user with ID has not authorized Coinbase. So now we can finally return the user.coinbase auth to the caller. So now back in our Coinbase auth service, we can make use of this and call get Coinbase auth with the user ID. And now what we want to do is we want to check to see if the access token is expired. So we'll have a new if statement here and say if new date .get time is greater than or equal to Coinbase auth .expires .get time. So what this is saying is if we are past the Coinbase expiration time. If we are, then we need to refresh the access token. So to refresh the access token, I'm going to create a new method called the refresh access token, which takes in the Coinbase auth. This is going to take the Coinbase auth object, and we're simply going to return the observable from http service.post. And the URL will be https www.coinbase.com/oauth/token. So this is the token URL that we've used before, but now the grant type we are using is refresh token. So the grant type is refresh token, and then we need to provide the refresh token. So if you recall, the refresh token on our Coinbase auth object is currently encrypted. So we need to call this .encryption service.decrypt and then pass in Coinbase auth refresh token to get the decrypted value. And then finally, we need to pass in the client ID and client secret. So I'm just going to go up to our first call to the tokens endpoint and pass in the client ID and secret like so. So now we're correctly refreshing the token. Let's reach out to this method here and set a new const response, this .refresh access token, and pass in Coinbase auth. Then to unwrap this observable, I'm going to call await last value from and pass in the observable. So now we have access to the underlying new token. We can call this .update user Coinbase auth, pass in response.data and the user ID, and lastly we'll return the access token from the response. So this was all if the token was expired. If it wasn't expired, then we'll simply return Coinbase auth.access token. And before we return the Coinbase auth access token directly, recall that this is encrypted, so we need to call our encryption service.decrypt and then have that token decrypted before we return it to the caller. So what I'm going to do is create a separate function here, an async function called getHeaders, which will return the headers for each request. So it'll take the user ID and it'll simply return an object that has the authorization header, and it's going to have the bearer, and then we're going to call await this .coinbase auth service get access token and pass in the user ID. So now we're correctly constructing this authorization header for each call that we need. And now in this call, we can simply provide headers and call await this.get headers with the user ID. So now we're ready to actually get the response. So I'm going to call await last value from, pass in the observable here, and then finally return response.data. And if we do receive an error, I want to throw error dot, and make sure we actually catch the error here. I want to return error.response.data, which is how Axios structures its error response. And lastly, we don't want to return response.data directly here, but we actually want to look over the data that Coinbase provides us and then find in there the account where the account.primary is true, because we want to get the primary account. So this expression here will allow us to do that. So now we have the primary account. We can retrieve it by calling this.get primary account and pass in the user ID. So now we have the primary account. We want to actually get the transactions from this account. So what we're going to do, keep our code clean and create a new method called get account transactions. So this will take in the account ID as a string and the user ID as a string. So this is going to look very similar to our get primary account method. I'll paste that in here. So the URL here is going to be a bit different. We're going to use backticks so we can interpolate some variables. Now we're going to call accounts and then provide the account ID and then call transactions because we want to get the transactions on that account. So now we can simply return this.get primary account transactions and then pass in our primary account.id and then pass in the user ID and make sure we call get account transactions here. So now we have successfully set up our code to be able to reach out to the Coinbase API and get our primary account transactions. So back in our Coinbase controller, we're going to add a new route here. It's going to be just a get route, and this will be the route to get the Coinbase data or our primary account transactions. And we're going to protect it with our JWT auth guard, and I'll call it get Coinbase data here. So we'll get access to the current user on their request, and this will return a promise of type any. And then we can return, then we're going to need to actually inject the Coinbase service first. So after we inject the Coinbase service, we can call this.coinbase service.get primary account transactions and then pass in the user ID. So now on our UI, we can reach out to our backend server and get our primary account transactions. So to do this, we're going to create a new API, Coinbase.api, and we'll follow the same pattern we've done before by exporting the API after we call create API, and make sure we remove the dist here from this import. And now in create API, I will give it a reducer path of Coinbase API. I'm going to have a base query here of fetch base query, and the base URL is going to be just /Coinbase, and then we can provide our endpoints here. So we're going to access to the build parameter, and then we can specify this query here, get primary account transactions, and we can specify build.query, and the return type will be any, and there will be no args, so we'll pass undefined. And then we can pass the query itself, which will be very simple. It's just going to be a URL with a root path. So now make sure we also import the fetch base query, and then we can export a const, set it equal to an empty object, set it equal to the Coinbase API, and then we can extract the use get primary account transactions query. So then, as we've done before, we'll have to open up our store again here, and then we're going to need to add our Coinbase API as part of our store. So we'll do what we've done before and specify the reducer path and set it equal to the Coinbase API.reducer. And then lastly, we're going to concatenate with the Coinbase API.middleware. So now the Coinbase API is part of our store, and it's accessible within our component. So I'm going to go ahead and create a new folder in our components folder and call this transactions. And then I'm going to create a new component called transactions grid that we're going to use to display our transactions from this Coinbase API call. So I'll create transactions grid.component.tsx. So as always, we'll import React from React here, and then we will create the transactions grid, which is going to be a functional component. It won't take any props. Now we're going to need the data, and we can extract the isLoading property from useGetPrimaryAccount transactions query, and then we can pass an undefined. So now we actually have the data here. So to do this, we can use Material UI in the table component they provide us. So we can go ahead and return, and then I'm going to wrap everything in a div here, and we can give it a class name of width 9/12, because I don't want it to take up the whole screen here. And then I'm going to give an h1 tag, or we can specify that this is the transactions. I'll give this a class name of text 4XL and a margin bottom of 6. Now we can use the table container here for Material UI React, and then we can specify the component that we want for it to use. And then we're going to use the paper component, and make sure we import the paper component from Material UI material. So now we can provide the table head. So we have a table head here, and we're going to wrap that in table row. And now we have table cells here where we can define the header rows for our table. So the first one is going to be the date, and then we're going to have another one, and then we're going to have another row here for type. So this will be the type of transaction, and we're going to want all of these other ones to be aligned to the right. So we're going to have the date of the transaction type, and then we'll specify the amount in crypto, and then we'll specify the amount in native, which will be the native currency amount. And then lastly, we will provide the status of this transaction, whether or not it's completed or pending. So that's all we need to do for our table header. And then we can have a table body where we can actually put the data itself. We're first going to check to see that we actually have data. So the data property lives on this data here that comes back from the server. The Coinbase API wraps everything in its own data property. So if we do have that property available, then I want to call data.data.map, and then of course map over the transaction. So the transaction will be of type any, and then we actually want to return some JSX in here. So for each transaction, we want to have a table row. The key for the row will be the transaction.id, and then we're going to provide an SX property, which will give it some styling when it's at its smallest point. So we can specify and last child as a selector, TD, and then and last child TH. We want the border to be 0. So now inside of this table row, we can have our table cells. We're going to specify the component type like we did earlier. In this case, it's going to be a TH, and the scope property here will be row. And in this table cell, this will be first the date of the transaction. So we're going to specify transaction.created@, and then we'll have another table cell. And this time it's going to have a line set to right, and we're going to have the transaction.type now, and then we'll do the same thing for the remaining table cells. So we'll have one for the crypto amount, the native amount, and the status. So these properties live under amount.amount, and then there is the native amount object, and under there we have the amount property. And then lastly for the status, that just lives under the transaction itself. So there's one more component we need to wrap things in, and underneath the table container, we need to actually include the table itself and give this an SX. We'll provide this a min width here of 650, and then give it an ARIA label of simple table. And then make sure we move this closing tag here all the way down until after table body. So before we close out the table container, we're going to open up a new tag here and check if we're loading data still. And if we're still loading data, then I want to have a div here and then use the circular progress component from Material UI. And then I'm going to give this a class name of flex justify center margin 6, just to center the loading indicator so that if we're still loading data from the server, we can show that to the user. And then of course, make sure we actually export this component. So now we can actually use this component if we go back into our home page here. So before we actually show the transactions grid, we need a way to tell if the user has Coinbase authorized or not. Because if they haven't, we're not going to be able to get any data back. So to make this easy, what we can actually do in our backend is if we go ahead and change the user's response to add a new property called is Coinbase authorized. And this will be a Boolean. And now in our user service, when we return build response, we can provide is Coinbase authorized, and we can simply check to see if Coinbase auth exists. If that object exists, then we know we've authorized them with Coinbase. So now let's go back into our DTO in our front end. So then on our front end and our user, we can add the same property is Coinbase authorized, which is a Boolean. So now back in our home page, we're going to need access to our user. So we can use the use app selector, get the state here, and then call select current user, passing in the state. And before we show the connect Coinbase button, we can instead check to see if the user has authorized Coinbase. If they have, then we can show them the transactions grid. Otherwise, then we'll show them the connect Coinbase button. So if we come back into our app now, we can see our table. You saw our loading indicator there real quick. And then we can see our data from our Coinbase API is now being correctly populated. So these are a list of transactions that I have done in the past through Coinbase. You can see the date, the types, buy, send, sell, the amount in crypto, and the native amount in USD, as well as the status. So now that we've authenticated with the Coinbase API and we have access to all of this data, I invite you to take a look at the Coinbase API docs. So I'll include a link to this in the description, but take a look at the docs that they provide here at all of these wallet endpoints, and actually use these endpoints to extract some additional data in your API and build out some new widgets, and really expand on this, because there's a lot more that we can do here now that we have authenticated with their rich API. In my next video, I'm going to show you how to deploy a Nest.js application using crypto stats as an example, using serverless. So if you'd like to see that video, make sure you subscribe, and thanks for watching. I'll see you in the next one.